This is week 5, asynchronous notes, and this is page 3. Example 2. So for the function t of x equals negative 9x minus 1 over negative 6x plus 2, we're supposed to find t prime of 3. Our goal then is to evaluate the limit as h goes to 0 of t of 3 plus h minus t of 3 all over h. Just like we did in example 1. And as in example 1, I'm going to go about this in a series of a few steps. The first 3 steps are concentrated on figuring out the numerator. That's where really the algebraic trickery and hard work is within figuring out the numerator. So let's go with that in a step-by-step way. And the first thing we'll do is t of 3 plus h. So that's going to be negative 9 times parentheses 3 plus h minus 1 all over negative 6 times parentheses 3 plus h plus 2. Look at that step carefully because it's key and sometimes a little bit tricky. In the function we have 2 places where there are x's, and both of those x's have been replaced by 3 plus h, and that's what that step entails. Now we work these guys out, so distribute the negative 9, so we'll get negative 27 minus 9h minus 1. And in the denominator, distribute the negative 6. So we'll get negative 18 minus 6h plus 2. That'll be negative 9h minus 28 all over negative 6h minus 16. That's step 1 done, which is to figure out t of 3 plus h. Now on to step 2, which is more straightforward really, to figure out the other thing in the numerator is t of 3. So that's plugging the number 3 in. So we're going to have negative 9 times 3 minus 1 over negative 6 times 3 plus 2. And then work this out. So negative 27 minus 1 over negative 18 plus 2 is negative 28 over negative 16. 4 goes into both of those, so we're going to have 7/4. 28 divided by 4, 7, 16 divided by 4 is 4, and a negative over a negative is a positive. That's step 2. And now on to the third step, which is to subtract. In the formula, in the numerator, we have t of 3 plus h minus t of 3. So that's what we want to calculate now, which is the difference of the two things we just figured out in the first two steps. So we have negative 9h minus 28 over negative 6h minus 16 minus t of 3, which is 7/4. So this is a fraction subtraction that we do have to carry out. It's a little bit tricky, but if you relate it to what's on the left-hand side of the screen, I think that's the way to go. A over b minus c over d. We don't have a, b, c, and d in our thing, but the basic essence of the math is over here on the left. So over there on the left, the denominators are b and d. So we'll use d times b for the common denominator. Now the first fraction on the left-hand example was a over b. From the common denominator, that's missing the factor of d. So we have to put that in the denominator and hence in the numerator. And similarly, but with roles reversed, the second fraction was c and d, c over d. So that had the d, but it was missing the b. So we had to put the b in the bottom and the top. And then we've achieved at that point d times b in both denominators. So we put the top, dA minus cb, over the common denominator, db. What we're about to do in our problem follows the same format as what we just did on the left-hand side. On the common denominator, what we need to do is the product, 4 times negative 6h minus 16. So what we need to do is rewrite this thing. I'm going to leave a little space for the CD work, like so. And then multiply the first fraction by 4 over 4. And I'd highly suggest to put parentheses around the binomial factors. Otherwise, later on, you're liable to forget to distribute. The second fraction has a 4 in the denominator. It needs a negative 6h minus 16 in the denominator. And so we have to put it in the top. So that step is like the second step on the left-hand side. The next step is similar to the third step, the third line. Second step, I suppose, third line on the left-hand side. That's putting over top our numerator over top of our common denominator. 4 times negative 9h minus 28 minus 7 times negative 6h minus 16 all over the common denominator of 4 times negative 6h minus 16. And we would not want to multiply out the denominator, but the numerator we do want to keep going. So we'll distribute the 4, so that'll be negative 36h minus 112 plus 42h plus 112 all over 4 times, leave the denominator like so. Well, 4 times negative 6h minus 16. So the 112s go away in the top, and we combine 42h minus 36h, so we get 6h over 4 times negative 6h minus 16. Now that's a lot of work. It's the third step done. It's most of the work for the problem. We're awfully close right now. But now the fourth and final step is to put use what we just got, put it into the formula and do the over h part and the limit part. So the fourth step is going to make use of what we just did in the third step. The fourth step is to do the limit of t of 3 plus h minus t of 3 over h. The limit as h goes to 0. So that would be the limit as h goes to 0 of this numerator, t of 3 plus h minus t of 3. That's what we just put all that work into getting. So now's the payoff to that, is that we put that right here in the numerator over top of h. And so there it is. What we got before is 6h over 4 times negative 6h minus 16 all over h. And then similar to example 1, we're going to want to do keep change flip. So I've put the h over 1 to create a complex fraction, and then we'll have the limit as h goes to 0 of 6h over 4 times negative 6h minus 16 times 1 over h. Keep change flip. And then the nice thing we can do there, which is a small thing in a way, but it's absolutely key, is cancel the h. And the reason that's key is because then after we do that, let's clean things up a little bit here. Then we're going to be able to plug 0 in for h. So we're going to have 6 over 4 times negative 6 h minus 16 after we cancel the h's. Now we can plug 0 in for h, and then we'll be in business. So that's going to be negative 3 over 32.